learn math for machine learning? Let's see. If you're a grad student and you have a curated curriculum in your grad school, you might end up learning all the fundamentals in the right sequence to learn ML. But I'm going to talk from the point of view of a general practitioner who is mostly trying to learn on the fly when they're doing something else, probably on the side, and trying to pick up some ML. So how do you get deeper into the math for machine learning? This is a question that I often get. So first, why do we need the math for machine learning? Understanding how the models work underneath helps us figure out what models to use when, how to tune the models better, how to find the right parameters, and so on. For instance, if I understand linear algebra, I could clearly see that if I have a lot of features and very little data, I cannot train a good model. So how do we learn math for machine learning? So I'm going to talk about the approach that worked for me and for a few others. So I believe in a top-down approach where you need to get your hands dirty first. So for instance, even before I actually went and learned all the math courses in grad school, I actually had an understanding of what ML does and how a basic ML model works. So for instance, you could actually take a small course or look at some videos to understand how models work. So what is supervised learning? What is unsupervised learning? How does an ML model take data and learn and make predictions? Ideally, you should get your hands dirty and implement maybe a couple of projects, at least regression and classification based stuff, to understand what regression is and what classification is. So once you understand what ML does, you can also appreciate at a high level what kind of math is associated with learning ML. Now, how do you go deeper there? So when you talk about math for ML, there are usually three focus areas: linear algebra, probability and statistics, calculus and optimization. Now let's look at each of these with an example, how it ties in with, some simple things we do in ML. And you'll also see like how a top-down approach helps you appreciate what you're learning better, because learning math in itself could be rather dry, and seeing where it can be used often motivates you to learn things better. So when I look at matrices and ranks in linear algebra, if I looked at regression before, it will help me appreciate the fact that regression is nothing but a set of overdetermined equations. So when I actually look at how to solve a set of overdetermined linear equations, I know that I can tie it back to regression that I've seen. When I learn probability and statistics, one can appreciate how the naive Bayes algorithm works for classification, or how the maximum likelihood estimate works for a model like logistic regression. Calculus and optimization helps one figure out how to solve loss functions, or you can represent your model as a function, and how do you find those parameters of the model that lead to the maximum or the best value or the least value for the loss function, the maximum probability or the least value for the loss function. So if I look at linear regression and I know the loss function for linear regression, which is just the sum of squares of the residuals, I might have seen that, but I might not know how to solve it. When I learn calculus and optimization, I'm actually learning how to solve it. And I can see that learning optimization, I can solve many other loss functions, or I now know that I can actually come up with new loss functions and I know how to solve them. So if you look at a few years ago, there weren't a lot of well-curated list of items that actually cover all these aspects. But now we are lucky because there are specializations available online that put together all these three aspects, and even Coursera, for instance, has an online specialization that covers all three of linear algebra, probability, statistics, calculus, and optimization. So there are multiple specializations. You might need to look at a few of them. Some might have a subset of these topics, but the important thing is to do all these three topics, and you will get a deeper understanding for math for ML. I would suggest once you actually do the math courses, you go back and look once again at all the ML videos from where you originally learned your models, or do an ML course online. And I'm sure you'll now appreciate the deeper get a deeper understanding of how these models work, and you will also enjoy the math behind the models. So hope you have fun building models and hope you also enjoy the math behind it. Thank you.